Hi, this is the third video where we're working through on a playlist the sample assessment materials for Edexcel, and it is the higher calculator paper. Now if you follow the link below in the description, you'll be able to download this paper and have a go at the questions for yourself. My plan is to run the video for about 20 to 30 minutes or so, so if you keep stopping and starting the video to have a go at the questions for yourself and compare your answers, you should be getting about an hour's worth of relatively focused revision. Okay, so let's go on then to question number 13. In the previous video we stopped at question number 12. Okay, so this particular question deals with an inverse proportion question, okay? And the difficulty with these types of questions is really you just need to make sure you read the English well first. So what it says is D is inversely proportional to C. Well, if D is inversely proportional to C, we can write that as D is inversely proportional. D is proportional to 1 over C. Okay, alrighty. Now, if then we change that into an equation, it says when C equals 280, D equals 25. Okay, so when D equals 25, it equals 1 over 280. Okay. Oh no, it doesn't. All right. What's missing here is something called the constant, and it's the bit that actually goes above here that when you divide 280 into it, you actually get 25. So the constant, they call it K. Okay, so I'm going to just change that at the top here to K. Now to work out the value of K, what we do is cross multiply by 280 and we get K equals 7,000. So in other words, the only way in which this is correct is when K equals 7,000, because 7,000 divided by 280 will give you 25. Okay, so we can use that now formula, and we can write this formula as D equals 7,000 divided by C to answer the question. So it says work out the value of D when C equals 350. Okay, well D equals 7,000 divided by 350, and either you can do that by mental arithmetic or work it out on a calculator, and you've got D equals 20, and that would answer this particular question. I hope that's okay for you. Please do check out some of the videos on the channel on inverse and direct proportion if you want a little bit of extra practice. Okay, so let's move on then to question number 14, which is one of these very popular questions. It isn't really a calculator question, it's one where we've got to prove algebraically that that is an even number. Well, all we mean is that whatever this works out as, providing it's divisible by 2, then it actually will be an even number. Okay, so let's just work that through. So I've got 2n plus 1 squared. Okay, well that, if I wrote that out, I'm going to write 2n plus 1 multiplied by 2n plus 1. Okay, now like before, one of the things I like to do is just be very careful about things like negative numbers by writing slightly different types of brackets. Now the reason I do that is because this negative sign will have an impact on the 2n and also the plus 1. This effectively will become minus 1 when you multiply out by a negative. Okay, so let's just concentrate initially on multiplying these two terms out, or these 4 terms out. Okay, so again, I'm very aware that people will do it slightly differently to me. What I do is I do 2n times 2n, which is 4n squared, plus 2n, plus 2n, plus 1. Okay, that's now going to be minus 2n minus 1, as I mentioned before. Okay, now the good thing about these sorts of questions is that actually, although they look a little bit scary to begin with, what usually happens is that you're able to make them just look a little bit neater, and I can, for instance, I can lose this plus 1 and this minus 1, and then I've got plus 4n minus 2n. Well, that's going to be plus 2n. So actually I get left, when I gather up the like terms, of 4n squared plus 4n minus 2n is plus 2n. Okay, now as I mentioned before, in order to say or to prove that this is an even number, it needs to be a multiple of 2 or divisible by 2. So all I can do is I can factorise these two terms by 2, and I can write 2, oh sorry, beg your pardon, plus n. Okay, beg your pardon, that's a plus sign. Okay, but the key point with this is that if I factorise this by 2, it means that I can say that because this is a multiple of 2, therefore it's an even number. Okay. Alrighty, I hope that's okay. I have about 4 or 5 videos on a playlist on algebraic proofs, so if you have a look at those on the channel, that'll give you some more examples of this. And I'm fairly sure this is actually the same question in one of those videos. I'm not entirely sure, I think so. Okay, let's move on then to question number 15, which there definitely is a playlist on, which is changing recurring decimals to fractions. Okay, very, very popular on these sorts of papers. Again, not particularly a calculator question, but something that you need to follow through. And providing you stick with the normal script and the way we do these things, then you should be able to work this through fairly well. So the standard way of doing it is you'll say something like let n equal 0.2. Now be careful, it's only the 5 bit that's actually recurring. So 5, 5, 5, 5, dot, 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 dot. Okay, so if we did that, then we can also then, by moving the decimal point, say that 10n equals, move this decimal point once, and I get 2.5555. And remember, the objective of this is to put yourself in a position where what you're doing is losing the recurring bit of the decimals. So if I take one away from the other, I end up with 2.555555 minus 0.25555. Okay, so I can get rid of all of these. So I end up with 5 minus 5, 5 minus 5, 5 minus 5, 5 minus 2, well that's going to be 0.3, and then 2 minus nothing is going to be 2. And then on the left hand side I've got 10n minus n, well that's going to be equal to 9n. So 9n equals 2.3. So if I divide through by 9, I end up by saying that n equals 2.3 over 9. Now, as you can see, that's not strictly the same as they got there. What they've got there is exactly right, because really you don't want to mix decimal points and fractions together. So all I'm going to do is I'm going to multiply top and bottom through by 10. Now if I do that, it means that the top would become 23 and the bottom would become 90, and that's the answer to this particular question. Okay, please do have a look at the playlist on some of those. There's some good examples in that. Talking about questions looking a little bit more challenging, question 16 does. There's quite a lot going on in there, and it's going to be tricky because essentially we need to factorise this bottom denominator, and that's where I think students will trip up a little bit. I think this one is fairly okay. And you do appreciate that you've really got two fractions here. So what we're going to do is we're going to multiply and flip. So actually, I could write this as 1 over 6x squared plus 7x minus 5 multiplied by 4x squared minus 1. But I do recognise this as being something called the difference of two squares. So what I'm going to do is I'm going to factorise this straight away like that. Okay, now if you're unsure about how I've gone from that to that, just have a look on the channel and look at something called difference of two squares, and that will give you a bit more information on that. But basically all we're doing is acknowledging that this is a square number, and actually 1 is also a square number, and we can then factorise in that way. Okay, the hardest part, however, of this particular question, bearing in mind we are at question 16 of this paper, so they are a bit tricky at this level, is going to be factorising this. Now, there is a method of doing it, and the way that we do that is that we multiply these two numbers together and we get minus 30. Now what I'm going to do is put that into a little box, because what we want to do is find two factors of minus 30 that when we add them together we're going to get positive 7. Okay, well, so for instance, if I could do 5 and minus 6. That could be two factors if I wanted, because 5 times minus 6 is minus 30. Well, there isn't any way in which when I add those together I'm going to get plus 7. I'm going to get 5 plus minus 6, so I'm going to actually get minus 1. However, there are two factors which are going to be plus 10 and minus 3. Now, it's actually those two factors that I'm interested in, because when I add those two together, I'm going to get plus 7. Okay, so what I'm going to do is rewrite this as the same thing, but I'm going to write it as 6x squared. And rather than writing plus 7x, I'm going to write plus 10x minus 3x, and then I've got minus 5. Okay, all right, so I haven't really changed it. All I've done is I've taken this plus 7 and said, well, actually the two factors of minus 30 are 10 and minus 3. If I add those two together, it's plus 10 plus minus 3, I'm going to get plus 7. Okay, remember, I'm not taking them away. I'm taking away, but I'm plus a minusing number, a minus number. Okay, so what I will do is post some videos on how to do this factorisation, because I think it is quite an important principle and something that really would be very useful for you to practice, because they are coming up quite a lot on these types of papers. Okay, so let's have a look at this. Now, the next stage with that is we look at the first two terms. Okay, and we factorise those two terms. Now, the biggest number that will go into both of those is 2, and the letter that's common to those is x. So I'm going to write that as 2x, and then what do I multiply 2x by to get 6x squared? Well, that's 3x. What do I multiply 2x by to get 10x? Well, that's going to be plus 5. Okay, so that's the first little bit. Okay. Then what I'm going to do is I'm going to factorise these two numbers. This is where, in this particular example, it's a little bit trickier, but I'm going to factorise it by minus 1. Because if I do that, what do I multiply minus 1 by to get minus 3x? Well, that's actually 3x. Okay, what do I multiply minus 1 by to get minus 5? Well, that's going to be plus 5. And really what you need with these is to be in a position where there is a common bracketed set of terms, okay, because the next stage then is to factorise this by gathering them together. So all we do is we take this 2x and minus 1 and we write that together, 2x minus 1, and then we multiply that by 3x plus 5. Okay, so that's actually, beg your pardon, that's actually the factorisation of this rather difficult one. Now, there are methods, there are ways in which you can do this, and that's perfectly fine, it's not a problem, but it is something that you need to have a method to do, because they are cropping up quite a bit with these sorts of questions. Okay, now you'll notice on the previous line here I've got 1 times that, and then here I've got all of that multiplied by 1. So I'm going to bring these two together. So I can write the top bit as 2x plus 1 multiplied by 2x minus 1. And that then gives me the ability finally to reduce this through by getting rid of the 2x minus 1s. So I can write that out as 2x plus 1 divided by 3x plus 5. Okay, and that actually is the final answer to this particular question. So it's taken a fair bit of time to work through. A lot of that is because of the factorisation of it. So please do find a way of trying to factorise numbers where you've got quite a high value coefficient, as it's called, of the x squared term. Okay, so I hope that's all right. We're not going to take much of a breather, I'm afraid. We're going to go straight on to question 17. But again, you might want to stop the video and just have a go at this particular question. Okay, so it says work out the length of arc AB. So this is this arc length along here. All right, not too bad, these sorts of questions. You've just got to remember that the circumference of if you have a circle, the circumference, the total circumference. Now, some people say pi d, okay. So you might write pi d. I tend to use 2 pi r. It's exactly the same because d is the value of 2 times r. Okay, so if I put that into this particular question, imagine it's a full circle with a radius of 7. Okay, so if I put that into my question, what I'm going to end up with is 14 pi. Okay, now I suggest that you don't work out with these types of questions the value with pi multiplied through, because you're going to be writing numbers all the time, because pi is going to go on for an awful long time. I think it's about 10 digits on a calculator, but it's a lot more than that. Okay, because really we can work out that value of pi right at the very end. And bear in mind, as I mentioned before, if you go back to the question, it says 3 significant figures. Okay, so we need to either way make sure that the final answer is rounded to the 3 significant figures. Okay, so the arc length, which is the bit we're interested in, okay, which is AB. Well, we haven't got a whole circle, we've only got a portion of that circle, and the portion we've got is 40 out of 360 degrees. Okay, so we have 40 out of 360 degrees as a full circle. Okay, if I multiply that by 14 pi, pop that into a calculator, and you're going to get this ridiculous 4.886921906 centimetres. Okay, and I'm sure it goes on a lot further than that. Okay, however, we need to make sure that we answer the question, so to 3 sig fig. Okay, remember again, look at the third significant figure, which in this case is 8. I'm going to change it to 9 because the number after it is a 6, which is above the 5. So that's going to be 4.89 centimetres, and that will answer this particular question. I hope that's okay. Alrighty, so let's move on. I think we'll have a look at question number 18, which is a question that involves bounds. Now, bounds are again becoming increasingly popular on calculator type papers, mainly because bounds really is all to do with tolerances. It's all about tolerance. So what we're saying is that if we have a measurement of 3.47, which is correct to 3 significant figures, then we could say that S, rather than 3.47, the lower bound of S is going to be 3.465, because if I then look at that number correct to 3 significant figures, it would be 3.47, because 5 is the lowest it could be. Now bear in mind, this is not rounding up or rounding down. What we're doing is we're looking at tolerances. Okay, so the upper bound of this is the same, if you like, the same unit away, the same measurement away from the middle value of 3.47. Okay, so actually I would write the upper bound as 3.475. It's 0.005005. Okay, so it's not rounding up or rounding down. Okay, it's the same with the value of t. This time, however, just to make it a little bit trickier, they've made it 4 significant figures. So we can say the lower bound for t is going to be 8.1315. In other words, that's the lowest value it can be, so that this number is correct. And then therefore the upper bound is going to be 8.1325. Okay, and then the question really is, it says, by considering bounds, work out the value of m to a suitable degree of accuracy. Oh wow, I think with these sorts of questions, they are a little bit trickier until you kind of just play around with it a little bit. So what they're saying is that by considering bounds, in other words, we've got to do this exercise for this value of m. So if we want to work out the upper bound of m, well, that's going to be the biggest number divided by the smallest number, okay? Because the upper bound must be the largest amount divided by the smallest amount. There's going to be a lot more of those in this because it's bigger. Okay, than if it was the other way around. So if we just pop that into our calculator, I then get, at the top, I'm going to get the root of 3.475. Remember, this is the upper bound, okay? And then the bottom is going to be the lower bound of t, which is 8.1315. Now, if I pop that in the calculator, I'm going to get, again, one of these horrendously long numbers, 0.229248643. Okay, and I've got to do the same exercise, really, with the lower bound, but this time, the lower bound of m is going to be the smallest number divided by the biggest number. Okay, so it's going to give us the smallest value. Okay, if I divide a very small number by a very large number, there's going to be a lot less of them. Okay, so again, let's have a look at that. By considering bounds, here we are. So this one, I'm going to do the root of 3.465, and that's divided by the upper bound, which is 8.1325, and that's going to give me, guess what, 0.229. Okay, but this time, again, bits, no, I beg your pardon, 0.22889. 903,839. Okay, however, if you have a look at that, correct to 3 significant figures, both those numbers are 0.229, correct to 3 significant figures. So what I would write in here is that m equals 0.229, correct to 3 sig fig. Alrighty, and that would be the answer to this particular question. Okay, so again, takes a little bit of time to work out these sorts of things, but you do need to just have a little bit of an awareness of working with bounds. I think we'll leave it there, and we'll start again in the next video with question number 19. If you're unsure about anything, please do add a comment below. I'll always come back to you. Please subscribe to the channel, and I'll look forward to seeing you inside the next video.